This lesson is on how to solve systems of equations using a method called elimination. Now, I previously taught my students how to solve systems using graphing and a method called substitution. I'll put links to those in the upper right-hand corner. So just quick review, a system of equations is just two or more equations. And when we're looking for the solution to those, what we're looking for is an XY ordered pair that will make both of these equations true. All right, so how does elimination work? Elimination involves adding or subtracting the equations in order to eliminate one of the variables. So, find the solution of each system of equations. Now, I want to get an equation that just has one variable, either the x or the y, so that I can solve for that variable. So in elimination, what you're trying to do is eliminate either the x or the y. And so when I look at these two equations, what I see is add these together, it would eliminate the y's because I have a positive 5y and a negative 5y. So adding those together, these will get canceled out. Add the x's together, and I get 8x equals 8. Divide both sides by 8, and x equals 1. So again, what I'm looking for is an XY ordered pair that is a solution to both of these equations, or in other words, makes both of these equations true. All right, so now that I have the x value, in order to find the y value, all I'm going to do is take this value of x, which is 1, and plug it into either one of these equations. Doesn't matter which one I plug it into. I'm going to plug it into the blue one just because it has all positives in addition, and so there's no subtraction or negative numbers, so I'm just going to choose that one. And so I'm going to take this and I'm going to substitute it in for x in this first equation. And so that's going to give me 2 times 1 plus 5y equals 17. And now I have an equation with just a y, and I'm going to solve this for y. So 2 plus 5y equals 17. Subtract 2 from both sides. Now I have 5y equals 15. Divide both sides by 5. I get y equals 3. So that's the other half of my solution. So there is my answer, or my solution to the system, 1, 3. And you can always check this. You can plug this into both of the equations and make sure that they both come out true. So if I plug in 1 for x and 3 for y, I'd have 2 times 1 plus 5 times 3. 2 times 1 is 2. 5 times 3 is 15. 2 plus 15 is 17. So it works for that equation. Plug it into this one, I'd have 6 minus 15. 6 minus 15 is negative 9, so it works for that one. So I know I got the right solution. All right, so here's another example. So let me go back here. It says that when you're using elimination, you can either add the equations together or you can subtract them. I think that subtraction gets confusing, so I tell my students not to use subtraction, only use addition. Now, if you look at this one, if you subtract these, the y's will disappear. But the problem is when you're subtracting them, you have to distribute that subtraction sign through here. And a lot of times students will make mistakes with that. So what I tell my students to do is multiply one of these equations by negative 1, so that I'll end up with a minus y, and then add them together. So what I do is multiply both sides of this equation by negative 1. So this gets distributed through here. Remember, you can do whatever you want to an equation as long as you do the same thing on both sides of the equation. So when I distribute that, I end up with, let me rewrite it down here, negative x minus y equals negative 101. And then let me bring down the other piece. 2.5x plus y equals 164. So now I'm going to add these together. So again, what I say is if you want to subtract, just multiply one of the equations by -1 and then add them together. You're less likely to make a mistake if you do it that way. So there's a 1 in front of this x, so that's -1 plus 2.5. So that would be 1.5x. Add these together, they cancel each other out. Negative 101 plus 164 is 63. Divide both sides by 1.5. Let me get my calculator out real quick. So 63 divided by 1.5 is 42. So there's half of my solution to the system. My pen just died. Hold on. All right, so there's half of my solution. I have the x value now. Terrible 4. Rewrite that. So the x value is 42. Now to find the y value, I just take this x value of 42 and plug it in to either of the equations. So probably the easiest one to plug it into is the original equation up here. So plug it into this one before I multiplied by -1. I could plug it into this one. I could plug it into the bottom one. All right. I'm going to plug it into this original one, x plus y equals 101. And so that's going to give me 42 plus y equals 101. Subtract 42 from both sides. And so y equals 58. So there's the other half of my solution. So my solution is 4258. And again, you can check that. You can plug it into both the equations and make sure it makes both of them true. All right. So this one is a little bit more work. So you can see whether I add these or subtract these, I'm not going to be able to cancel out the x or the y. It's not going to work. But again, remember, you can do anything you want to an equation as long as you do the same thing to both sides. So what I recognize here when I look at this is if I multiply this bottom equation by 3, that will give me a minus 15y here, and then these will cancel out. So that's what I'm going to do. So I'm going to multiply these by 3. I got to multiply both sides by 3. So let me rewrite this over here. So I have negative 2x plus 15y equals negative 32. And here I have 21x minus 15y equals 51. Now I can add these together and cancel out the y's. So those will cancel out. Negative 2x plus 21x is 19x. Negative 32 plus 51 is 19. Divide both sides by 19. And I get x equals 1. So now I need to plug this in. So that's half my solution. Now I need to plug this in to either equation and solve for y. So let's plug it into the bottom equation. I could plug it into the top one. That would be fine. So when I plug that in, I get 7 times 1 minus 5y equals 17. So that's 7 minus 5y equals 17. Subtract 7 from both sides. Now I have negative 5y equals 10. divide both sides by -5, and y equals -2. So there's the other half of my solution. And there is the solution to this system. And as always, you can plug this in and check it. All right. So what can I do here to be able to cancel out either the x or the y? Well, I can't just multiply one of the equations by something to cancel something out. So I'm going to have to multiply both of these equations. And so what I'm going to do, let's cancel out the x's. All right. So if I want to cancel out the x's, I'm going to make one of these x's a positive 12x and the other one a negative 12x. And then when I add them together, they'll cancel out. So let's multiply this one by -3. And let's multiply the top one by positive 4. That'll give me a 12x and a negative 12x. I could have done the same thing with the y's. I could have multiplied by -2 to make this a -6y, and this one by +3 to make it a +6y. So those would cancel out. You can do it either way. So we're going to distribute here, multiply both sides by the value. And so in the top, I end up with 12x plus 8y equals 4. In the bottom, I end up with -12x minus 9y equals +6. So the negative and the plus make a minus, the negative and the negative make a +6. And now I can add these together and cancel out the x's. So those will cancel out. 8 minus 9 is -1y. 4 plus 6 is 10. Divide both sides by -1. Y equals -10. So there's half of my solution. That's the y part. Now to find the x part, I plug this in to one of the equations. So I don't know, let's plug it into, well, we'll plug it into the bottom one. But you could plug it into the top one. That would be fine also. So I'll plug it in for y here. I'll plug in -10. Or I should say substitute. That's what we're doing, substituting here. So I plug that in. It gives me 4x plus 3 times -10 equals -2. So 4x minus 30, because that comes out to -30, equals -2. Add 30 to both sides. 4x equals 28. Divide by 4. And x equals 7. So there's the other half of my answer. And again, you can plug that in and make sure it makes both of those equations true. All right. So what if when I do the elimination, what if both of the variables cancel out? So I lose both the x and the y. Well, if you end up with two numbers that are equal to each other, it doesn't have to be 2, it could be any number. If you end up with a true statement, one number equals itself, then that means that there are infinitely many solutions. The same thing happened when we did substitution. So infinitely many solutions. If both the x and the y cancel out and you end up with an untrue statement, then that means there is no solution to the system. All right, so that's elimination. So I hope that was helpful and useful to you. If so, give it a like and a subscribe, and please feel free to leave me a comment. Until next time.